What happens when a limit is going not towards a regular point, but to infinity? Well, in simple cases like this one, as x gets bigger, the output just keeps getting bigger. So the limit goes to infinity. In other cases like this one with sine, it's just going to keep going back and forth no matter how big you make x over here. So you would say that the limit does not exist. Where it really is important to be thinking about what happens when x goes to infinity, though, is for cases like this one, where as you make x bigger and bigger and bigger, the output of the function gets closer and closer and closer to 0 until it basically is 0. And in this case, we would say that the limit is 0. Now, where it gets more interesting is cases like this one, where you have different types of functions, like x squared and x cubed here, or e to the x, or natural log of x, and they're all competing with other functions for which one is going to go to infinity the fastest. So there's a general rule that you can follow for which of these functions is going to win. In the case of this one right here, you look at the largest power, which is the cubed here. So the limit would go to 0 because the denominator, x cubed, is going to get way bigger than the numerator, x squared, as it goes to infinity. For cases like this one, you would pay attention to e to the x, because e to the x is going to win out over just plain old x on the top. And so you would say that it goes to 0 for the same reason. And finally, for this case, you can reference the raised to infinity, and you'll see that the square root function is going to beat out the natural log function, which means that it's just going to go to plain old infinity here because the numerator wins. And finally, for cases like these ones, when you have a sum in the numerator and denominator, you can cross out and just completely ignore any term that isn't the largest value. And if the largest value happens to be the same type of term, then it'll become a ratio of the two, as we see right here. And when you have cases like this one where you're going to negative infinity, you treat the negative sign as a substitution. And so you would look right here, and you see that there's the fourth power. And so the fourth power cancels out the negative sign, meaning that you just have the one negative sign left attached to that 5, which means that the answer is negative infinity.